Saxon Algebra 1/2, Lesson 77. Here I am, back in your life, ready to talk to you about more math. I know, you're so lucky. So am I, because I get to tell you about it. Today we are taking a spin with our old friend, the frickin' formula, percent version. Remember that this is a formula that we can use to take a group of things and divide it up according to a percentage. Now, normally what we do is we have a scenario that looks like this, right? We take the group, this is the before, and it always represents 100%. And then we have the after. We've divided the group in some way. Let me make up an example. We have a parking lot that has 80 spaces. And on game day, we need 60% of them for game day. Where am I going to write that? Up here. Game day needed. Oh, let's write needed. 60% of those parking places are going to be needed on game day. So that tells us, because we know this has to add up to 100, 40% are not needed. Okay, and then we can use these percents. We multiply by the percent over 100 times the original number, and we get that 48 of those spaces are needed on game day. And then we can either multiply this way by the other percent times the whole group, just like we did here, or we can subtract this from the total and we find out that 32 of the parking places are not needed on game day. Okay, this is when our percent is less than 100. All right, I use different symbols for percent. Play along, okay? What we want to talk about in this lesson is, and let me just write, this was parking spaces. Right, so we have a lot that has 80 spaces in it, okay? Now, we have the same 80 spaces, and it's parking spaces. Let me write that again. Let me write before, and again, this is 100%. This time, it's not just an ordinary game day. It's the really big game. It's the really big game of the year. And we need more than 80%. We need 120% of the usual parking spaces that are available to us, right? On normal game days, we only need 60%. We need twice as many. We're expecting that crowd to be a lot bigger. So this time, our freaking formula still works. It's just gonna look a little different. So let's just look how that works. Our percent is 120. We put it over 100. We multiply by the total group, which is 80. I'll put it over a 1 so it doesn't look weird. And that's gonna give us the number here. I'll call it W. And John does that just so that the words from the sentence match the equation. What number? At first, it feels really weird to use 2 letters for a variable. You can do whatever you want, right? You could write shoe there if you wanted. Variables can be named however you want to name them. John's goal, and I agree with him, is to make them as logical as possible. Okay, so all we have to do is simplify this. I'm going to go 20 into 80 4 times, 20 into 100 5 times. And then I know 5 is going to go into that evenly. Let's see, 5 into 100 is 20 times, right? I take care of the 100 and ignore the 20. Now I'll pay attention to the 20. 5 into 20 goes 4 times. So that tells me 24. So I can cancel this. That's 24. That's 1. I know, I'm going kind of fast. I'm just showing you how I do that in my head. Do it however it feels comfortable to you. And so I multiply 24 times 4, and that's going to be what? 96, right? So that means For the big game, we need 96 parking places for all of the fans that are going to come and cheer on the Mavericks. I don't know, whoever they are. I'm trying to think, what's the name of the team in High School Musical? Wildcats, right? Aren't they the Wildcats? I think they're the Wildcats. Oh, P.S. One of my daughters reminded me the name of the cowboy in Toy Story is Woody. Duh. Come on. Get with it. And they assured me they were not too old for Toy Story. In fact, my youngest daughter is like the same age as the Toy Story kid, whatever his name is, because she went to college the same year that, what was it? I don't remember if it was 3 or 4, the Toy Story where that boy goes to college. She's the same age as him. Oh my gosh. Okay, so sometimes when our percent is greater than 100, we're looking for a number that's greater than the whole. Here we were looking for numbers that were less than the whole, and our percents were less than 100. Here we're looking for a number that's bigger than the whole. Okay. And by whole, I'm talking about W-H-O-L-E. I'm calling this the whole. So this is percents greater than 100. And that's our topic for today. So now we're going to do 3 versions of a problem. And in each one, we're going to have a different variable. Make sure you have this in your cover. Pause me right now if you don't have it in there. You know what? Pause me anyway and go check and make sure you have this written down. I'll wait. Okay. It's fun, you guys, because I don't really have to wait. I just say pause me, and then I give you a second to pause and then unpause. But you're off doing your thing, and through the miracles of technology, I don't have to pause. It's kind of fun. Okay, so make sure you memorize this and know what it's for. Right? This is a formula that allows you to take a group of things and either divide them up if the percent is less than 100 or grow them to a bigger number if the percent is greater than 100. This is super useful. Memorize it. Okay, here's part A. 210%, by the way, it's an A, B, and C. A. 210% of 50 is what number? Okay, look at how easily this fits into the formula. There's the P over 100. I can write 210 over 100. There's the of number times 50, I'll put it over 1, is on the other side, and what number I'll put in as my variable. It's so simple, I love it. Okay, 50 into 100, right? It goes twice and once. Now 2 into 210. That's 105, right? Chop that in half. Now I've turned both of my denominators into a 1. So I know I'm done. 105 times 1. What number is 105? All right. Normally, we're going to draw the pictures for these all the time, but right now we're just practicing solving the equation, so I'm not going to do it. For our last example of the day, we will actually draw a picture that looks like this. All right. Ready? Let's do part B. This is example 77.1. It's part B. P over 100 times of equals is. That's the magic charm of the day. B, what percent of 40 is 60? Now, we might not notice that the percent is over 100 in this one. It doesn't matter. We're fine. We're just going to go, what percent, that's the mystery, over 100 times 40, and we'll put it over 1, is 60. And we'll put that over 1. I don't know if that's going to be helpful or not, but whenever I'm dealing with fractions, it makes me feel better. Okay, here's our variable. Now, We're multiplying all of this together. So the fact that these are two separate fractions, it doesn't really matter to us. We want to use the reciprocal to get rid of both of these. This is a little bit sort of like an advanced reciprocal move. I'm going to put 40 on the bottom because then that will cancel. And then I'm going to put 100 on the top, and then that will cancel. So even though these two guys don't look like they're a single fraction, technically they are, and we can create a reciprocal that will make both of them go away. Yay. See how it top and bottomed? Now I just have to do this over here. 140. Okay. Let's do a little canceling. 20 goes into both of these. Twice there. 3 times there. 100 divided by 2, I can say that's 50, and this will be a 1. Now my denominators are both 1, so I know I'm done, and I get what percent equals 3 times 50, 150. Oh, okay, that's right. By the way, has a really crooked-eyed smile, isn't it? This one was right. I didn't box it. Oh my gosh. I hope you guys gasped when I turned the page without doing that properly. Crazy business. All right, and now we'll put the variable in the last place with part C. 150% of what number is 300? Okay. I'm jotting down the problem. I'm substituting numbers instead of the words, like they write out 150% in letters instead of numbers. So I'm abbreviating a little bit, and they say what number, I just write WN. But I'm literally taking the words and turning them into a formula using this as my guideline. 150 over 100 times what number equals 300. I'm going to put it over a 1. Beautiful. This one to me is the most fun one. I like it doing it this way. We'll do 100 over 150 to make the reciprocal do its job. 100 over 150. Aha! 150 goes into 300 twice. I'm going really fast. That's a problem, isn't it? Sorry. Once, twice. And so we get what number equals 200. All right, this was all just to remind you that this is a formula with 3 different parts to it, and John will give us 2 of the 3 and ask us to find the third, and we can do it any way we want. All right, I mean, we can solve that easily, no matter what. Okay, last example. This one we'll practice drawing the picture. It's a story too. I think they're more interesting when they're a story. Ready? Jane, oh, that's my third daughter's name, Jane or Janie. Jane is mad because today crullers cost 120% of what they did 2 years ago. What does a cruller that was 60 cents 2 years ago cost today? Work the problem and draw a diagram. Here's the tip I have for you first. Number 1, if you haven't had a cruller, you should get a cruller because they're delicious. Go to a donut shop. I live right by a donut shop in Mukilteo called Henry's Donut. I'm telling you guys, if you're ever in the Mucktown, stop by and grab some. Okay, so number 1, have crullers. Number 2, start the diagram, do the algebra, go finish the diagram. That's my advice. Okay, so here's Jane's drama. This is the price of crullers before. Now, the price has gone up. So that tells us it's going to be what I like to call a toddler baby Jesus. Because, like, can you see? Here, let me draw them. I think I talked about this before, right? Doesn't that look kind of like a little sleeping toddler baby Jesus with his swaddling clothes wrapped around him? Right? He's just a little peanut. He's happy. He came to save the world, man. He's happy. There's his halo. Or it also looks, no offense, baby Jesus, it also looks like a peanut in the shell. You know what I'm talking about? Kind of like this, right? And you crack it open and you eat the 2 halves. This style of problem, the percentage is greater than 100, I think of as either toddler baby Jesus or peanut. Okay. So this is what the price was before. This is the price after. So both of these are price of crullers. C-R-U-E, isn't it? No. Just like this. I think they're German. I'm not sure. Crullers looks like a German word though. Okay. She's mad because they cost 120% today of what they did 2 years ago. So we know that this percent is 120%. And the before is always 100%. No matter which kind you're doing, the before is always 100%. What does a cruller cost that was 60 cents 2 years ago? What does it cost today? See how I did that? This is before, this is after. So in our scenario, this is like 2 years ago or whatever it was. Yeah, and this is now. They cost 60 cents 2 years ago. They've gone up 100. They've gone to 120% of what they were before. So we're all set. Ready? We're going to do it in cents. We're not going to do it in dollars. That's okay. So here's my formula. 120 over 100 times 60 over 1 equals what number? Yay! All right, so let's break this down. Everything's on one side. We don't have to use the reciprocal, right? Our variable's already alone. We just have to simplify. And I know 20 goes into this 3 times and 20 goes into that 5 times. There's a 1. Now we can do the 5 into 120. See how the numbers... John is so nice about these numbers. He always makes them turn out cute. All right, 5 into 120. I'm going to do 5 into 100 goes 20 times, and 5 into 20 goes 4 times. See how my brain did that? 5 into the 100, and then 5 into the 20. And then I add those two pieces together, and I get 24 and 1. My denominators are both 1, so now I just have to multiply 24 times 3. If it was 25 times 3, that would be 75 cents, right? Like 3/4. But this is 1 less, so I subtract 3, right? Instead of it being 75, it will be 3 less than that because I'm multiplying only 24 times, not 25 times. So 75 minus 3 is 72. So those freaking crullers. Today's crullers. Woo! They are breaking the bank. No wonder Jane's mad. My daughter Jane does love a tasty donut too. Although she's more about, she likes a maple bar and she likes just a nice chocolate frosted kind of a thing. Let me make sure that's the right answer. Yes. Yay. Now, one last word about John. John drew his diagrams like this. They have the same numbers in them that I do, but don't worry about that. That's confusing. John is drawing them with squares instead of circles. In other books, when he covers the same kind of problem in different levels, he's going to use circles. I like the circles much better. I don't like the squares. So you can do squares if you want, but I will choose to do circles because, you know, I'm a rebel like that. All right, percents greater than 100, the freaking formula. We have now learned all the different ways to use it, and we're going to play around with these percents for quite a while. We really aren't going to talk very much more about percents and decimals, those versions of this, but the percents we're going to play around with. This is a very true to life, how do you figure that out kind of problem. So learn how to do this and you'll impress all your friends when you get older because they'll forget all their algebra and you'll be like, oh my gosh, freaking formula, you guys. Where were you in 8th grade or whatever it is? 7th grade for some of you. Is that right? 7th or 8th grade? You guys are all 7th graders. Yes, you're 7th graders. I'm sure of it. Okay, I'm going to go now. Goodbye.